So this is concerned to the power. So before going, what do you mean by power, sir? I'll discuss the power here before doing the sum. So what do you mean by power, sir, here? Power is nothing but a rate of doing work. That rate of doing work. So what is this rate of doing work is? So P is equal to, that is dW by dt. So that is work needs to be completed in a specific amount of the time, or it can be written as an work done divided by this is your time. Okay, now this is your power conditions. So in this case, what is an instantaneous power means what? Instantaneous power is equal to P is equal to force into velocity F bar dot V bar. This can be directly get from this one. Power is equal, power also is scalar quantity only. So work done is force into displacement by time. So what is this displacement by time is velocity. So that is F bar dot V bar. It is an instantaneous power, you can call this. Okay. So what are the SI units of the power is? SI units of the power is watts, or in most cases we'll be also using the horsepower. That is 1 HP, 1 horsepower is equal to how much? 746 watts. Like this, it can be written as in. Okay, so power can be written in the, depend upon the necessary or the situation, it can be converted into the different formats. So power can be written as in, that is P is equal to, as we know, F bar dot V bar. So velocity or force, if I write the force as an dV into this is dm by dt. So day before yesterday we have seen there is the loss of motion. Force can also be written in this one. So which is equal to the v square into that will be dm by dt. So like this also for the situation, or it can be is equal to, well, our mass can be written as an volume into density and everything. If I write that particular thing, half into area into density into velocity q. So that means it's the most important relation. Power is proportional to the velocity cube. Don't forget this relation. Now coming to this particular sum, 12 HP motor has been operated 8 hours a day. So in a day, 8 hours, it's been operated, it's a 12 HP. So how much he is asking, the how much it will cost? Uh, that is in 10 days, if the 1 kilowatt hour, if 1 kilowatt hour is 50 paisa, so how much it's going to be cost? Let's convert this particular HP power value into the watts. So power is equal to 1 HP is equal to 746 watts, means 12 HP will be 12 into 746 watts. This is your power. So now with this power, total energy, how much time it is being used? So energy can be written as an energy used is equal to power into time. So that implies 12 into 746 watts into, now what is the time? 8 hours a day. Can we convert the 8 hours into seconds here? So 8 hours means 8 into 3600. How many days you are using? 10 days. So this is the total energy. This is the total energy that is being utilized. So now this is the value. What is the energy for 1 unit? In the sense 50 paisa, in the sense 0.5 rupees only na. So rupees 0.5 are used for uh, per energy, that means per 1 kilowatt hour. Kilo means 10 to the power of 3. Watt hour means 3600. So 0.5 rupees are being used for this much of the energy. Then for this total energy, how much you need. So you can go for the cross multiplication and you can solve this one. 12 into 746 into 8 into 3600 into 10. This is your total energy into 0.5 by, so what is that particular value Andi ikkada? So next value is going to be 10 to the power of how much? 10 to the power of 3 into this is 3600. This is the total amount. Total amount. So 3600 you can remove here. 110 square and the 10 will be left over here. So which is 12 into 746 into 8 can be 8 into 0.5 is 4 into 10 to the power of minus 2. So you can multiply this entire thing and you can substitute there. So all the values are nearby. So we need to go for the precise calculation for this one. It's going to take a much longer time here. So this is the type. So power formula is F into V is an instantaneous power, and general formula of the power can be written as an dW by dt. In some situations, work done will be only in the form of kinetic energy. In some cases, work done can be in the different potential plus kinetic energy. For example, like this. So pump of a power can be power of a pump which can pump 200 kgs of water to a height of this. So that means here work done is in the form of work done is in the form of which energy? In the form of potential energy. Potential energy. In the sense work done can be, or the power will be written as an W by T, which is equal to the mgh by T. So the power you need to find it out, mass is 200 kgs into G10. You need to lift it to a height of 200 meters in 10 seconds. These two will be cancelled. So your answer will be the 40 kilowatts like this. So in some situations, work done can be only kinetic energy. In some situations, work done is both the kinetic energy as well as potential energy. Okay. So like that, we need to be solving. Fine, ma. So different types of the case. Now, if I come to the energy, so we will be discussing only the conservative energy and basically the mechanical energy. Mechanical energy is divided into two parts: kinetic energy and potential energy. Once again, show third one. 1 second. Yeah, this one, huh? Okay, can I go for the next one, Anna? Thank you. Right. So energy, kinetic energy, and you are only dealing with mechanical energies here. Potential energy. So kinetic energy is by virtue of the motion. Potential energy is by virtue of its position. So what is the general formula that we write for the kinetic energy is half mv square. But the potential energy you can write it as an half kx square for the compression or elongation, or for the axis you can also take it in terms of an change in the position. So you can write it in whatever may be the format, or if f is equal to minus of kx, minus sign represents for the only opposite direction. If I want to replace the k is equal to f by x, then the same formula will be turned out as an how, sir? Half into this is f into x. So like that I can also eliminate the x and also write in terms of the f and the k. In the sense, if I write, this will be the half f square by k. So depend upon the situation, you can use any relation over here or availability of this one. Now, what is the potential energy? potential energy between two charges. As you have completed the second year also, so I'm going for both of them and the second year potential energies as well as first year rendu kuda cheptunnan nanu. So what is the formula? 1 by 4 pi epsilon naught. This will be the Q1 Q2 by RA kadandi with a negative sign potential energy conditions. Okay na, so alane gravitational potential energy ఉంటుంది. So everything will be there like this. Okay na, so now what is the next point if I go? So the ratio of potential energy of a body, the ratio of potential energy of a body taken, suppose if I want to take to a height h from surface of earth, can be, that is change in potential energy or work done will be equal to the delta P change in potential energy in this case, where here H is equal to N times of R, then the same formula can be written as an N by this is N plus 1 into this will be equal to the mgr. So in this way you can write the potential energy for the different situations and the different cases, but the kinetic energy is going to be this way. Okay, so for the what is the potential energy for a gravitational thing? Next one, gravitational potential energy. Gravitational potential energy. Generally, the potential energy is expresses the instability of the body. If the potential energy is more, that means that body is more unstable. If potential energy is less, that means that particular body is more stable. That will be G M into small m by R, or the same thing can be written as n minus this is mgr. Got it? So like this, potential energy is different things. What is the relation between F and potential energy? Then give for conservative forces. For conservative forces, what do you mean by conservative forces? The energy will be stored in the one form. Actually, it will have the energy in one form. Depend upon the situation, that energy can be transferred to the other form. So only for the conservation nature, it can be written as a minus dou u by dou r. So this is the force, basically relation between the force and potential energies.